Okay, good morning. Today we're going to be talking about compound inequalities, 3.6. A compound inequality is an inequality that consists of two distinct inequalities joined by the word and or the word or. So an example of an and would be a compound inequality using that's where it's going to be in between. It means it's greater than and less than 18. So anyone who is at least 14 years old and is not older than 18 may attend the dance. So compound inequality, just think of a compound word. It's two words put together. Compound inequality is two inequalities put together. An example with or, discounts available at the movie theater if you're elderly, 65 and older, or under 8 or 12. So it doesn't include 12, so it's anything younger than 12, but it includes 65 or older, so it includes the 65. Another way of writing x is less than or equal to -1 and x is less than 2 is -1 is less than or equal to x, which is less than 2. Notice in the bottom method, both signs are pointing the same direction and the smallest number is on the left. So -1 is over here. When you're combining them, a compound inequality, you're going to combine the graphs, but you're going to adhere to both of them. So this one, that it's greater than -1, x is greater than -1, we go this way. X is less than 2, we go this way. It's where they meet. So if I were to color this one green and this one blue, it's where the blue and the green would meet, which would be right here. Okay. A compound inequality containing the word or is true if one or more of the inequalities is true. So one or more. So x, because it could be either or. If x is less than or equal to 1, so less than or equal to 1, x is greater than 4, so either or could be true. Just like that example, you don't have to be both 65 and older and 12 or under 12 because that's not possible, right? It's got to be an or. You have to be either or. Draw a line from each description. And real quick. Each description in column A to the inequality it describes in column B. So all numbers less than 9 or greater than 5. So all numbers, that's going to be my x. So x is less than 9. So I could think of this one. This would be x is less than 9 or greater than 5. So x is less than 5, this one will not work. This one, x is less than 9, x is less than 9 or greater than 5. There we go. Sorry, it took me a second. Because x is less than 9 or x is greater than 5. Okay, all numbers less than 9, so I'm going to look for that one, and I'm going to look for my and. So this could be this one, or yep, both of these two. This one would be out because it has an or. So less than 9, x is less than 9. Right here, this one is x is greater than 9, so I'm going to this is probably going to be the one, but I'm going to check out the rest. And greater than 5. So x is greater than 5, or 5 is less than x. See, I can read this part right here. I like to read it sometimes x, and because this is open towards it, I can say x is greater than 5. In my head, I can turn it around and say it like this, which this means the same thing in my head, so I know I'm right. Let me get this out of here. Okay, so this one would be to this one. Did I do that right? Let's check it. Less than 9 and greater than 5. Yes. Okay, all numbers less than 5 x is less than 5 and greater than 9, and x is greater than 9, so that would go here. And the last one, all numbers less than 5, x is less than 5 and greater than 9, that would go there. All right, so writing the inequality represented by the graph. So I have to look at this graph, and I'm going to write an inequality. So this is going to be an and because it's going to meet. This is going to be an or because it's either over here or over here. So I'm going to start with my -3. So x is greater than, so this is my greater than. Does it equal it? No. So it's greater than a -3. And x is less than or equal to 3. So I can write this as my compound inequality. My -3 is going to go first. Remember, this is pointing to the -3, so I can turn that around and put x in the middle. And now if you look here, it's pointing towards my x, so I can write it like that. Okay, what about this one? Let's go write this one first. X is going to be less than -2. It does not equal. Or x is greater than, does not equal it, 6. Okay, let's go this one. -3 is my number here, so we're going to remember the shaded part's my x. So x is less than it or equal to a -3 and equal to, sorry. And this is going to be an or. X is greater than, because this is my x, not equal to 4. Okay, we'll do one more and. So I'm going to do my work over here. X is going to be here. X is greater than or equal to 2. And then over here, my 8x is going to be less than or equal to, I think I said greater than over here. I meant greater than or equal to. I messed that up a lot, sorry. 8. And now because it's an and, I'm going to put it like, write it like this. 2 is going to go first. Remember, it's pointing towards my 2. My x is going to go in the middle. Again, if I look here, it's pointing towards my x. Okay, and 8. This can never switch signs like pointing towards the 8. I could not put it like this because that's completely switching this sign. You can't just switch the sign. You can switch it only if this comes with it. Like this one, it turned in, this is a greater than. This turns into a less than sign, but it's still open towards the x. Okay. So writing in a compound inequality to represent the phrase below, graph the solutions. All real numbers that are greater than or equal to -4 and less than 6. So all real numbers, it's going to be represented with my x. So I'm going to start by working my problem out that are greater than or equal to, -4, and I could say x is less than 6. So if I were to write my compound inequality, I would start with my smaller number, make sure this is pointed towards it, x, and then if I were to write my 6, add that together. Now remember, these two signs are facing the same way, and then if I were going to graph it, I would go, this is going to be a really terrible graph, just because I'm trying to go kind of quickly, but -4, I would graph this one first. So x is anything greater than or equal to -4, so it would be a closed dot, and it was going to be, I'll highlight it, anything this way. And then 6, it does not equal 6, but it's going to be less than 6, so open dot, and then anything less than it, and it's going to be where the purple and the green mix, so I'll make it one more color, and I would shade in between there. All right, so now when solving compound inequalities, separate the inequality into two separate problems. Isolate the variable, write the final answer using the word and, or its shortcut, or the word or. Graph the solution on a single number line. And graphs, no arrows, they meet. Or graphs, arrows in both directions. So and graphs, no arrows are highlighted, they meet up. So it's going to be in between. And the or graphs are going to be, the arrows are in both directions. I don't know how to stop this.